This is another charger that has been sealed with glue. Honestly, I really don't feel like repairing this kind of charger. A colleague brought it to me, and it has been sitting here for many days. He said it hasn't been used for long, and this charger is still relatively new. He wants to fix it and keep it as a spare. Now its problem is that when power is applied, there is no response. First, we power it on and take a look. Let's measure the input voltage. 232 volts. The input voltage is normal. Now let's remove this glue first and then measure where the problem is. The board has been removed. This charger only has glue on the front side. The back side is not glued. On the back, there's only an insulating plate. I've repaired several Yadea chargers like this before. Those had glue on both the front and back. I don't know why this one doesn't have glue on the back. Maybe they forgot, or maybe they cut corners. Anyway, it saved me a lot of effort. Now let's measure and see where the problem is. First, measure the fuse to see if it is blown. The fuse is not blown, so there should be no short circuit. Next, measure the bridge rectifier. The bridge rectifier should be fine. 0.5, 0.5. The bridge rectifier is okay. This power supply does not use a separate switching transistor. It uses an SPY1808 power chip, which integrates the switching transistor and control chip together. This is the first time I've seen this type of chip used in a Yadea charger. I also couldn't find the pin definition of this chip. Let's roughly trace the circuit and see the function of each pin. Here is pin 1. Pin 1 goes through two resistors in series to the positive terminal of the large capacitor. These two resistors should be the startup resistors. Then from this side, through another resistor for current limiting, then through a diode to one end of the transformer winding. The other end goes to the negative terminal of the large capacitor. This winding should be the secondary supply winding. It is rectified by this diode, then goes through a current limiting resistor, this is a 30 ohm resistor, then filtered by a capacitor, this small capacitor, and finally goes to pin 1 of the chip. So pin 1 is the power supply pin. Here is pin 2. Pin 2 is connected to pin 4 of the optocoupler, so pin 2 is the voltage feedback pin. Here is pin 3. Pin 3 goes through 3 resistors in parallel. These 3 resistors are all 0.75 ohms, then to the negative terminal of the power supply. These 3 resistors should be the current sensing resistors. So pin 3 is also the source of the switching transistor. Here's pin 4. Pin 4 goes through a resistor to ground and connects to the negative side of the power supply. Pin 4 should be the timing pin. Here is pin 5. Pin 5 is directly grounded. Pin 5 is the ground pin. Here is pin 6. Pin 6 connects to one end of the transformer winding, and the other end goes to the positive terminal of the power supply. This should be the primary winding. Pin 6 is equivalent to the drain of the switching transistor. Now let's measure the chip to see if it has any problem. Measure pin 3 and pin 6. These correspond to the source and drain of the switching transistor. 0.5, no problem. Measure pin 1 to ground. Also, no short. Measure the current sensing resistors. 0.48, also no problem. Now let's power it on and measure whether the 300 volts is normal, and then check whether pin 1 of the chip has supply voltage. First measure the 300 volts. 325 volts. The 300 volts is normal. Now measure the supply on pin 1 of the chip. You can see that the voltage on pin 1 is jumping back and forth between 9 volts and 18 volts. Measure the output voltage. Output voltage is 0 volts. No output. Now power off. Let's measure whether the secondary supply has any problem. Measure the current limiting resistor, 30 ohms, no problem. Measure the rectifier diode, 0.5 volts, also no problem. This kind of power supply actually has a very simple primary circuit. Apart from the power chip, there are only a few resistors, and all of these resistors measure fine. After careful observation, I found that the primary winding has signs of cracked solder joints. Let me show you with a magnifying glass. It's these 2 solder joints. Through the magnifier, you can clearly see very small cracks. Let's look at a good solder joint for comparison. Without a magnifier, it's very hard to spot this problem with a naked eye. Now let's resolder these two joints and see if it works. These two solder joints have now been repaired. Now let's power it on and see if it works. You can see the indicator light is on. Let's measure the output voltage, 55.8 volts. Output voltage is normal and stable. Now measure the supply on pin 1 of the chip, 14 volts, also normal and stable. So this charger is considered repaired. It was caused by these two cracked solder joints, which resulted in no voltage output. Normally, for chargers that are fully glued like this, electronic components, including the transformer, are not easy to develop cracked solder joints. I don't know why this transformer did. After that, we resoldered all the large solder joints, and now this charger is repaired.